Okay, this is a topic that's very similar to a topic that we've had before, which was called coin problems. And remember in coin problems that we came up with two equations, and then we used either substitution or elimination to solve the equations. And that's kind of what we're going to do with these value problems. Let's take a look at example one. In example one, it says airline fares for flights from Tifton to Adel are $30 for first class and $25 for tourist class. So in other words, for each person that's riding first class, they pay $30. For each person riding in the tourist class, they pay $25. Now it says if a flight had 52 passengers who paid a total of $1,360, how many first class passengers were there? So what we need to do is we need to try to develop two equations and then use substitution or elimination for them. Now before we start out, let's think about how we're going to designate our letters or variables for the different classes of people here. So what I'm going to do first here, I'm going to let NF represent the number of first class passengers, and then I'm going to let NT represent the number of tourist class passengers. So let's use those variables and let's see what we can come up with now. First of all, we know that the flight had 52 passengers, a total of 52. So we know that the number of first class passengers plus the number of tourist class passengers total 52. So that's one equation I've got. Now the other one is kind of like coin problems, where we use the what each one is worth, for example. Now the equation that I'm going to use then is, let's see, how much is a first class passenger have to pay? And the answer to that is $30. So I know that $30 times how many first class passengers there are will give me the total money that first class is paying, plus $25 times the number of tourist class, okay, equals. Now we got to give this a little thought on how we're going to designate this. Now in this case, remember in coin problems when we had the 5, for a nickel, 5 cents for a nickel, and 10 cents for a dime, we had to make sure the final amount was in just cents. Now what's the 30 and the 25 in? Is that cents or is that dollars? Well, it's dollars, right? So this is okay. I can leave it because that's dollars. So I have $1,360 then is what that's equal to. Now what I need to do is solve it. And this is set up for elimination. So remember, there's a lot of different ways I could do this. I think what I'm going to do here is I'm going to multiply the top equation by 30, or excuse me, by a negative 30. So I'm going to work on getting the NFs to cancel out. All right, so I'm going to multiply the top equation by a negative 30, and I'm just going to try to put that in there right there. So I got a negative 30. I got to multiply everything by a negative 30. Plus a negative 30 NT equals, now if I take 52 times a negative 30, I have, and I'm going to write it above the 52 here, I have a negative 1,560. Okay, then I'm just going to cross that out because that replaces that. All right, now let's add the columns together. So a negative 30 plus 30, they cancel. What's a negative 30 plus 25? And I have a negative 5 NT equals, what's a negative 1,560 plus 1,360? So in other words, if our same type of temperature example, say it's a negative 1,560 degrees below zero, which is really cold, and the temperature goes up 1,360, well, it's still below zero, and it's a negative 200. Now solve it for NT. Divide both sides by a negative 5, and I find out that NT then is equal to 40. So the number of tourist class passengers was 40. Now, How can I figure out how many first class passengers there were? Well, what I do is I go back to this first original equation. The number of first class plus the number of tourist class add up to 52. So what I can do is take 52 and take 40 away from it. I get 12. So the number of first class passengers were 12. Now if I check this and I took $30 times the number of first class passengers, and if I took $25 times the number of tourist class passengers and added them together, I should get that $1,360, and I do. So we did this correctly. All right, one more example. It says Watts Dress Shop sold less expensive dresses for $20 each. So the less expensive were $20 each. The little bit more expensive ones were for $45 each. Now the shop took in $1,375 and sold 20 more of the less expensive dresses than the more expensive. How many of each kind did they sell? So what we're going to do here is we're going to come up again with two equations. So let's come up with the equation that's going to involve the $1,375, or in other words, what each dress was worth. Now I need to think about how I'm going to designate the variable. So I'm going to say that, let's see, $20 for a less expensive dress, right? So I'm going to say N of L, L standing for less expensive, plus the more expensive were $45. So if I take $45 times the number of M, more expensive, equals, now 20 and 45 is dollars, so I got to make sure my total is in dollars, which 1,375 already is. I don't need to change it to cents because 20 and 45 is in dollars. So that's one equation. Now the other equation is kind of like those coin problems. I'm going to write down an untrue equation. So I know that the number of less expensive dresses does not equal the number of more expensive, because it says there's 20 more of the less expensive. So if this were a science balance, all right, there's 20 more over here. There's 20 more of the less expensive. So this side of the balance is lower, right? So how do I balance that out? Well, I got to add 20 ounces, or however you want to think of it, over here. So what's my equation? Well, my equation then is NL, the number of less expenses, is equal to the NM plus 20. And that's my other equation. Now I'm going to erase this over here. You can rewind this and refer back to it if you need to. But now this, how do I solve for my variables? Well, it's really set up for substitution, isn't it? So I know that, I know what NL is. It's this right here. So I'm going to substitute that in right there. So I have 20 times that couple of NM plus 20 plus the 45 NM equals 1,375. Now I'm going to distribute, so I have 20 NM plus 20 times 20 is 400 plus 45 NM equals 1,375. Now simplify, so combine your like terms here. So 45 and 25 is 65 NM plus 400 equals 1,375. Now if I subtract 400 from both sides, okay, so if I subtract 400 and then divide by 65, and I guess I'm going to have to squeeze this in up here. So if I subtract 400, I get 65 NM equals, let's see, 1,375 minus 400 is 975. Now divide both sides by 65, I get NM, or the number of the more expensive dresses, is 15. So how many dresses were more expensive? 15. Now what place can I figure out the least or the less expensive, the NL? And the answer, that's right there. So NM, which is 15, plus 20. So the number of less expensive would be 15 plus 20, which is 35. So 35 were less expensive. Now if I checked it, easy to check. If I take NL times $20, and I took the NM, or more expensive, by $45, and if I calculated and added together, I would get $1,375. So as you can see, these types of problems are very similar to coin problems. They're actually easier because we don't have to convert everything to cents in one of the equations.